Hello students, in our last lecture we have discussed the change of state of matter and effect of change of temperature. Today we will discuss effect of change of pressure. By applying pressure and by lowering temperature we can change the state of matter. We have already discussed that the difference in various states of matter is due to the difference in the distances between the constituent particles or the interparticle distances between them. So by increasing or decreasing the pressure we can change the state of matter. We can take an example of gas in a cylinder provided with the piston. Now compress the gas by the piston. The pressure is applied, the interparticle distance decreases and the gas particles come closer. So they start attracting one another strongly to form a liquid. And if we compress more by the piston, the particles will come more closer to each other. So by applying pressure and reducing temperature, we can liquefy the gases. So by applying pressure and reducing temperature, if we cool the gas, the kinetic energy decreases. Kinetic energy decreases means the particles will move slowly and the interparticle distance decreases and the forces of attraction increases between them, which pulls the gas particles closer to form a liquid. So by applying pressure and reducing temperature, we can liquefy the gases. We can take the example of solid carbon dioxide. It is stored under high pressure because it gets directly converted to gaseous state without coming into liquid state. This is the reason why solid carbon dioxide is also known as dry ice, because it does not goes into the liquid state. It directly goes into the gaseous form, gaseous to solid and solid to gaseous. That's why it is known as dry ice. So we can say that the pressure and temperature determine the state of a substance, whether it will be solid, liquid or gas. This can be explained by this interconversion diagram, and you have to draw this in your notebook also. Solid gets converted into liquid is known as fusion. This we have discussed. And liquid convert back into solid is known as solidification. Liquid gets converted into gas is known as vaporization. When gases condense back to liquid is known as condensation. Solid directly to gas or gas directly to solid known as sublimation without interconverting without coming in the liquid state is known as sublimation. Now we have discussed both the effect of temperature and pressure on the conversion of states of matter. Now the time for the assignment. Now first question is, explain with the help of diagram latent heat of fusion, latent heat of vaporization and sublimation process, all the three with the help of diagram. In latent heat of fusion and vaporization, you also have to show why the temperature does not rise while changing or converting their states. And in sublimation process, you have to draw with the diagram. Either show with camphor, ammonium chloride, make the diagram and explain the process. Now next question is, convert the following temperature to Celsius scale. Before doing this question, I'll explain it to you. Now Kelvin is the SI unit of temperature, that is 0 degrees Celsius is equal to 273 Kelvin. To change a temperature on the Kelvin scale to the Celsius scale, what you have to do, you have to subtract 273 from the given temperature. For example, you have given temperature 673 Kelvin and you have to change it into Celsius scale. So what you will do, 673 minus 273, 400 degrees Celsius will be your answer. Now next example is 300 Kelvin Then you will subtract 273 from it. 27 degrees Celsius will be your answer. Now next is to convert a temperature on the Celsius scale to Kelvin scale, you have to add 273 to the given temperature. Example, you have given 28 degrees Celsius and you have to change it into Kelvin scale. So what you will do, 28 plus 273, 301 Kelvin will be your answer. Suppose you have given 243 degrees Celsius, so 243 plus 273, 516 Kelvin will be your answer. Now in this question you have to convert it into Celsius scale and you have given 300 Kelvin. So what you will do, you will subtract 273 from it. What you will get, 27 degrees Celsius is your answer. In second part 573 Kelvin is given. Then what you will do, minus 273, 300 degrees Celsius is your answer. Now next question is what is the physical state of water at 250 degrees Celsius. 250 degrees Celsius means the water start boiling at 100 degrees Celsius. So above 100 degree it will be in vapor state or gaseous state. In B part is 100 degrees Celsius. 100 degrees Celsius, it is the boiling point of water. So at this temperature water will be in liquid as well as in gaseous state, both the states. At boiling point the liquid will in both the states. Now next question is, for any substance why does the temperature remains constant during the change of state? During the change of state of a substance at its melting point or boiling point, temperature remains constant because the heat energy is supplied to the substance is used up in overcoming the forces of attraction without increasing the kinetic energy. So the temperature remains constant. Here is the answer. The heat energy is used up in changing the state by overcoming the forces of attraction between the particles. Now next question is, suggest a method to liquefy atmospheric gases. Here is the answer. Applying pressure and reducing temperature can liquefy gases. This is all for today. Do all these questions plus the activity questions with the diagram in your fair chemistry notebook.